wheel, you see this is K of the wheel, I think we call it. K of the car, B of the car, mass of the car. How many velocities are there?
Two.
You got these, obvious, right? Below the ground, not this. That's not ground. Moving. So ground doesn't move. Okay? Does that make sense to people? The ground is our reference, is where everything's zero. If the road is moving, it's not ground. The input. What kind of input? Velocity input. Right? Not a force input, velocity input. So this is like the pothole in the road. Drive along here, the tire drops down the pothole, goes on. Will the tire move the same with a smart car as a Suburban?
No. No.
Yeah.
Yeah.
The road will provide whatever force is needed. Doesn't care what tire is dropping into it in that pothole. Right? So this is not ground. That is the velocity. This is the input to the system. So there are 4 nodes in this. That makes sense to everybody? And it ends up being one order system. How many state variables? 4 orders. Yeah, we always get in this habit of like touching ground is, or the roadway or whatever is ground, it's not. Right? Think of an earthquake. Is the surface of the earth ground? Well, it's moving. An earthquake in Central Italy, the earthquake. There in the hotel. So, yeah, be careful of these things. All right. I had a lot of questions primarily on this one. And then the other question people had is, what goes in the tree? It is a hierarchy. First thing that goes in is what?
Input.
Cross sources, which we have here. Yes, no? Yes. Second priority is what? Cross storage elements. Third priority is anticipated for transducer problems here. Right? Next priority, here's the root storage elements. Never goes into the tree through sources. Okay? Monograph is causal, same word. Right? So causality slashes. We use appropriate direction for that. That element, if it goes the wrong direction, it means it's not stable. All right. So in this case, yeah, I think this is the tree, that's the tree, and then the springs are in the lake for the active states. Other question people had is the directions of these sources. So let's talk about that with respect to. Look at the resistor. Look at the currents that direction. What can I say about the voltages? Is V1 greater than V2, or is V1 less than V2?
V1 is greater.
Why?
Because there's a drop.
Because if I'm pushing the current that way, that's going to be higher voltage than that. Okay? Why? In fact, you might think of a rule here is for these cross variables is the direction for the current things is the tail of the arrow minus head of the arrow. V1 minus V2. let's look at that for a source. Fact. For this view of the road. And you've got all the other things connected. So now I'll look at the source of this. Should the arrow be pointed down, or should the arrow pointed up? If this is view of the road. Which is down. Right? How do you point it down? Because I'm looking at VR minus 0 is VR. Okay. Does that make sense? So you might think of this as kind of the internal forces, or if it's a voltage system, kind of internal currents, battery. So, maybe way of thinking of it. But if you do that rule, your sign draw is correct. Right? So one of the techniques with the fine graphs, linear graphs, and the other technique is rules to make sure your signs are correct. Right? Okay. Force acting on us. Let's do the linear graph for the second. What happened? How many wasps? 2. All right. Right. Okay. The mass actually is arbitrary. I'm pointing down to the moment. Let's look at this force. Should it be up or down? Well, let's find out which way is this. Easy thing to check. In fact, I happen to know. What's the equation for this system? Real simple. Right? Do the second law. Half of t equals mass times v dot. Have to know that. All right, let's see if the graph, whatever, gets you the same answer. So, let's assume up. We'll test that first. So Kirchhoff's current law says sum everything going in and out will sum to 0. So that says I have f of t going in minus fm going out will sum to 0. And Fm, according to a rule, is what? Tail of the arrow minus head of the arrow. V minus 0 dot. Do I get the right equation? Yeah? No? Yes. Yeah. Right. Let's reverse this. We want the mass to go the other way. What changes? That changes. Right. They're all entering. And this changes. But now, force of the mass is what? 0 minus t. 0 minus v dot. Right? Do I get the right equation? Yeah, I get the correct equation. So it doesn't matter for these classes on what direction I put the arrows. Right? Just make sure I'm consistent all the way through. Let's look at this stuff. Let's assume it's down. Right? And choose the same one. So I have minus f of t of some error is positive plus fm 0 or minus f of t equals minus m, which is minus mass, still correct sign. Positive over here, negative here, that's all right. Doesn't matter. Let's change this direction. That's going to minus. Still incorrect. So what's the rule for through straight lines? So think of a rule here for through straight lines. I mean, that's through source. So for source, what direction should the arrow be? Up or down in this case? Up. Right? And I get that right. What if I did this? It's perfectly valid. Put your velocities towards the new way. Which way would the arrow be then? Be down. Right? So think of this harmonic. A positive force causes what? A positive acceleration, positive change in velocity, therefore points towards it. If a positive force causes a negative change in velocity or acceleration, it should be pointed down. All right? Does that make sense? Yes, no? No. Right. Questions on this? So, for sources, these are not arbitrary. For a cross source, let's say the ground, arrow must be more arbitrary. So across source A is equal to A1 minus A2 if it's pointed down. Okay? For a through source, pointed up if it causes an increase of the velocity. This is exactly the same thing as in contrast with the flashes. Absolutely different. Yeah.
Say that one more time, so it fits in.
All right, for a cross source, all right, it will produce A1 minus A2 if the arrow is pointed that way. If the arrow is pointed the other way, it will be A2 minus A1. Okay? So tail of the arrow and head of the arrow. And for a through source, it will be pointed towards the node that it's trying to increase A2 here. Pointing towards it. If it's pointed away from it, then it will decrease A1. Okay? Does that make sense for everybody? Yes.
I'm still a little hung up on the why the M goes away from the V. Is it because it's kind of
M
resistant?
goes away from the V.
Back
Oh,
on.
this is, I mean, the direction here is.
Yeah. Is it
It's
reason?
arbitrary.
It's arbitrary. Okay.
Yeah, it makes no difference. What matters is how I do my sums here, though.
Okay.
But this one matters. All right? That one absolutely matters. And in this case, it would be correct. You pointed down. In this case, it's going to be pointed up.
Okay.
And that is not arbitrary. If you do that, your signs will be correct. Otherwise, you get a minus sign showing up. Okay? Questions on this? Understand this? Yeah.
I have one question. It's not for like I seem to keep getting when my masses are in parallel and series wrong, so I was just curious what like the general rule of that
Well,
is. So like in this problem,
Series and parallel mean what?
well, it's when your through variable is like, if it gets
If it's in parallel, what do we know about the through variables? No, are they the same? If they're in parallel? No, it can be different. What is the same if it's in the elements in parallel? Cross pairs. If it's in series, what's the same? Through variable. Right? What's the difference? Cross variable to that. Now, if I have two masses truly in parallel or two masses truly in series, I'm going to lump them as one mass. Because they're going to be essentially doing the same thing. There's no reason to have two separate masses. That's actually a redundancy that you can just eliminate right off. I have two capacitors in parallel. Eliminate it. All right, that's redundancy. You know, or in series. You can just say, okay, here's the equivalent single capacitor or resistor or anything else. So you eliminate those right off and you say, these two resistors are in parallel. Okay, I know the rule for resistors in parallel. Get rid of two of them, make one. That makes sense to people? The nice thing about that is you're kind of eliminating all the redundancy or extra, possibly extra states that don't mean anything. All right. I want to continue. I want to talk a little bit about some other transducers. Let's look at a piston. And you can generalize this to not just pistons, but all kinds of hydraulic, other types of devices. So on one side I have fluid flow, maybe some volumetric flow, and it has some pressure. On the other side I have some velocity and some force. This piston of some area K. What are the relationships between all these? What's the relationship between, say, pressure and force? Well, dimensions can tell you. Pressure is in force per area. Right? So pressure must be equal to the force per area. And if I have a volumetric flow, so Q is volume flow. That's so many cubic meters per second, or gallons per minute, or whatever else units you want. Right? What does that relate to?
Velocity.
Velocity, how? Well, flow is in what?
Yeah.
Linear dimension cubed per time. Velocity is linear dimension per time. So how do I go in? Times the area. I have a certain change of volume in this thing. It's how much it moves down the x times the area. That's the match up. That makes sense to everybody? All right. The one difference here is the way I've drawn it, is I have a flow coming in here. Is the velocity going to be in that direction? Yeah. So that would say that if I have pressure here, I'm going to opposing force that way. So one of these